The sites in these sections fulfill the conditions for kelp planting and have a rich variety of landscapes types, but these landscapes are not linked to each other and the policies implemented are independent. Based on our previous finding and the proposed development potential, we could try to link the land and sea industries in this region and develop business stacking in conjunction with the existing technology. Depending on the current situation, this profile also has urban agricultural land, natural areas, and horticulture land. Some of the vegetables are grown using agroecological farming techniques. This is a simulation of the scenario of our project. We will use kelp, oysters, and reeds to purify the water over the next 5 years. Oyster beds and kelp beds need to be cultivated first. After 10 years, when the water quality is up to standard, they will be sold to the urban area or recycled. For example, kelp can be supplied as a natural nutrition for land-based cultivation, and oyster shells can be used to store undersea reefs. Next is the land area. This is the status quo. Existing problems of monoculture can be solved by means of the agroecological techniques, such as intercropping of maize and wheat, and the introduction of a kranza and its companion crops, which are beneficial for soil nitrogen fixation. According to the policy, potatoes can be intercropped with root companion crops, while trap crops can be grown to avoid pesticides use. The policy of management of hedgerow, although implemented, still need to be maintained by complementary policy in order to protect the habitat. We can create blocks of the pollen and the nectar to provide food for birds in the winter. In the vicinity of the vegetable plot, according to the planting advice provided by the ALC and the guides of the CS technology, we can plant some fruit trees. Next is the horticulture area. Again, we can grow some high-value crops such as strawberries and flowers on this land. The horticulture area is equally open to further agri-technological research. In summary, we suggest that in the future it will be possible to link farms in each of the same industries for technology exchange and harmonized management. While exchanging technologies, we can develop industries to stack up and sell the researched product to different areas. Below, we have listed 6 raw materials that could be used for the development of the industry in this region. These materials can also be used synthetically, such as oysters and kelp can be used as organic fertilizer for crops. Reeds can be used as roofing, headering, and wine material for building farms and greenhouse. As a summary of our project version, we have combined policy and agroecological techniques and applied them to different landscapes of the Chichester, creating a continuity in the landscape that meets the government's version of the creating and protecting diverse habitats. We have retained some of our original crops and industrials while existing problems has been ameliorated. At the same time, many jobs has been created as a result of the development of these industrials. A sustainable, self-efficient economy can bring many benefits to the growth of the Chichester.